Hello, this is Fumihiro Kato. I'm a co-organizer of this workshop. Next, in the final speaker of the morning session, it gives me a great honor to welcome Professor Furukawa. He's an associate professor in the Department of Informatic Engineering at the Graduate School of Information Science and Technology, Osaka University, Japan. His research interests are focused on the development of intelligent informatics, cognitive sciences, human interfaces, and interactions based on virtual, augmented, and mixed reality. He studied the novel telexistence surrogate robot system TELESAR V. Today, his presentation entitled this. Okay, the stage is yours.
Thank you for your introduction. My name is Masahiro Furukawa from Osaka University in Japan. I'm going to talk about the Tsumori-Control, robot control method based on the control intention. The Tsumori is Japanese word, very simple. Please remember Tsumori today. Let me introduce myself. As introduced from Kato Sensei, I was working on the TELESAR V project from 2010 in Keio University. And also, I'm currently working on the Osaka University as an associate professor from 2020. So, as shown as here, the human robot is very important for the future technology. Then there is a high demand for remote controlling. Then there's two ways to make the human robot intelligent. The first one is to make an autonomous system, and the second way is the human in the loop, as previous presentation told. Then my position is to take the second way, the human in the loop. Then human and robot has very many degrees, to control. Then, from my stance, we have to build an intuitive human interface. Then also, if we can do it, for example, the left figure shows the additional prosthetic arm on the back. If you can control these prosthetic arm as you imagined, this is gonna ultimate goal of the human robot interaction. And I'm working on the TELESAR V. The TELESAR V is a fifth series of the telexistence system, as known as a telepresence system.
Separate. Okay. Oh, I see. Wow, it's good to see you. It's good to see that you're very. No, so right now I'm VP of TAB, Technical Activities Board. So I'm running like meetings, TC meetings, and those kind of stuff right now.
I'm sorry, please. Okay, thank you for meeting. let me restart. This is the TELESAR V. I was working on this project. The telexistence system requires us to transfer our bodily behavior into the remote place, and the robot have to realize our behavior level. And also, we can perceive the remote perception as including the vision and sounds and haptics. In this video, this video shows you will perceive as your own body with the robot itself. But the telepresence or telexistence system require us to build a complex and expensive robot sometimes. And also it's very difficult to control intuitively by human. Then the easiest way is to measure our behavior movement with a motion control camera, and also the any body movement measurement system. But there's two issues to do so. Then firstly, the first issue, the robot is very expensive and very complex. The Tsumori-Control Tsumori-Control allows you to use a very simple and cheaper robot as shown as here. This is a hobby purpose robot, but it looks like humanoid. Then if you can control this robot as you think. But there's a second issue. How can we do that? Especially, I try to introduce this way. If do you imagine how you can control this humanoid robot with only 2 sticks? I will introduce how. The keyword is Tsumori. Tsumori is Japanese word, very simple word. Please remember Tsumori. We consider the Tsumori as intention, especially the behavior intention. Behavior intention is, please try to take a look at this video, the small window. The behavior movement is continuous. Continuous behavior, when we see the continuous behavior, and try to imagine that, please realize this continuous behavior. For example, punching and kicking and so on. When you remember this kind of continuous behavior, what we will do is to split into the static or specific static frames into several numbers. Then when you do this continuous behavior, you will combine these static frames into the one unique continuous behavior. This is a reproduce sequence when you see some continuous behavior as well as the reproduce that unique continuous behavior. So the discrete part, we think the discrete part as a memory. Then we can say that Tsumori equals to the intention as well as a memory. So the Tsumori works as a memory. That is the first message. There is evidence. So we asked the participant to split this video in order to tell this continuous behavior with another person. But you cannot show this video itself. What you can do is only split frames to give the split frames. Then we also asked the participant to select the frames as smaller as possible. This is the result. The vertical axis shows the participants and the horizontal axis shows the time. So all participants choose the similar. We can say that the perfectly same frames in this video. Then this shows that our memory as discrete, in other words, the static frames, as long as we can see this continuous behavior. Then, if we can understand this kind of continuous behavior as a static specific poses, the system can estimate these kind of static frames in order to evaluate or in order to understand what you will do or what you are going to do. Then we try to evaluate that hypothesis. This is a movie of the robot. This robot is the same as shown before, a humanoid robot, but it's very small and it's very cheap. The key point of this Tsumori-Control is this kind of continuous, looks like a continuous behavior, but sometimes the robot stops. When you see the stopping of this humanoid robot, you tend to remember these key features as a keyframes. But this robot keeps going, keeps moving. Then the video looks continuous, but your memory increases with the static specific poses. Then this movie, we consider this movie as Tsumori, as a discrete feature, discrete memory. The Tsumori-Control system uses this kind of setup. As I told you before, we use only 2 sticks, but it's not just 2 sticks. The one stick has 4 sensors, 6-degree of freedom force sensors, 3 translational forces, and 3 torques. Then we put the 2 in order to measure the 12 degrees of freedom in total. Then the participants asked to sit in front of the display as well as the 2 sticks. And he will hold these 2 sticks as shown as here to push the force into the sticks. But this person will see the movie at the bottom. The goal scenario is like this. The user has some behavior, continuous behavior as Tsumori. Then they decided to do this behavior as a robot. They push the 2 sticks. Then robot will behave correctly. This is the goal sequence of Tsumori-Control. The starting point is human. The goal point is robot. The succeeded scenario has the correct intention will be realized at the robot. The Tsumori-Control system will have the additional sequence. We call the extracting as intention sequence. The extraction means bind this force pattern to this motion pattern. The starting point was different from the before. The this time, starting point is robot. The first robot moves automatically. Then the user look the behavior. Then this is the key point. This user asks to push the force as if you control the robot at this time, in real time. Then after that, we can obtain this kind of time series data sets with based on this continuous behavior. Interestingly, this continuous time series data sets has several features. This graph shows the horizontal axis shows the time, and the vertical axis shows a normalized force or torque data. So the bottom graph shows decreasing the error compared with the last pushing pattern. The left top graph shows graph seems like having a large divergence, but the right top is very converged one. So the human, this graph shows the user tends to converge into the one specific, a unique behavior while watching this video. In other words, okay. In other words, the user, okay, the user decided to one unique behavior with one unique continuous behavior. And also this graph shows the system will be easier to estimate which movement, which motion is correct. The background system looks like this. The input, we use several systems, and this is a neural network one. The input layer has time series data sets, and the output layer is the probability of movement. The movement is segmented from the specific pose, and also the output layer gives the probability of each specific poses. Then this is one scenario. If you push movement, if you push the behavior A, the correct answer is the output layer, the cell of behavior A has a higher value and the other one has a lower value. That is the correct scenario. This is the result. B and A shows the segmented continuous behavior. the B and A, the between B and A has one unique static pose. And also the end of the A has also static pose. Using the past and correct frames, the answer must be A because the correct input pattern binded to the A. Then the correct rate is up to 80% using 4 past segments. That is acceptable one, we think. And interestingly, there's another different features of this Tsumori-Control. So, but the previous legislation shows that you push the force while as a motion pattern A, but the system correctly answer A after pushing A. There's a delay. So this illustration shows that you currently are pushing as a motion pattern B, but you already decided to do A next. Then what happened? What happened is this system can correctly know what you will do next, because the current pushing pattern is B or Y, then actually you will do next as A. The system can correctly answer the A much higher than the chance level. So this result indicate that our behavior output has a future intention, not current intention, as well as a future intention. That's very interesting part. Then finally, this is a demonstration of this system. This students tries to follow the Go video to match to make the same pose. The video is Go, and the actual robot try to follow this video sequence, and the robot behavior is not recorded. He was doing in real time. So this is the final slide. The Tsumori-Control is a kind of intention, and also we think the intention works as a discrete memory. And also, please remember the word of Tsumori. And this is a lot of members, and I very appreciate you invited me here, and I appreciate to thank you for all other students and funding. Thank you very much.
Thank you for presentation, Professor Furukawa. Any question in person or online? Do you have?
I have a question about the Tsumori-Control. Yes. Does it have any advantage to compare to the VR-based control or AR-based control?
Yes, we think there's an advantage, and also AR and VR system can be easily used to extract our real-time behavior in order to find what we will see and what we will grab, and then the AR system is very suitable to realize the Tsumori-Control system.
Okay, thank you.
Thanks so much.
Thank you. Any other question? Can I have a question?
Yes.
The Tsumori-Control, you introduced the Tsumori-Control is a fast short memory, discrete memory. Mm-hmm. But you also mentioned that include the future intention. Mm-hmm. I think yes. that this point is very interesting. Mm-hmm. So my question is, From the user operation, can we produce the future forecasting movement? Does it
You mean this system can reproduce the future behavior itself?
Yes, future behavior. Just produce the behavior from the current operation.
Yes, it's possible, and also we have some evidences to shows the same result. But the time is very limited. Time means that the very short time. It's possible within the very short time, like several hundreds milliseconds or less. Yes.
So is there a possibility to expand the more future movement? There is possibility. Is there a possibility to expand the more future, for example,
the longer
or 1 or 2 second future movements?
I think it's possible as long as the behavior is very limited. Because this video doesn't have a lot of sequence. The number of sequences is very limited, but not around a dozen. But if the system can handle all pattern, I can say it's possible.
Oh, okay.
Within several seconds or more.
Okay. Thank you. Thank you for
Thank you
answering.
very much.
Any other question? Okay. Okay. Let's finish this session. Thank you, Mr. Professor Furukawa.